This is the final exam review for Math 1010 Intermediate Algebra. It's been a pleasure to be your instructor. Hey, we have 50 problems total, and these problems are the exact same as the problems you have in your review. I just have specific numbers with mine, right? So go ahead and go to whatever review problems you want to address, and you can do them with me. You can fast forward to wherever I am in the problem set for your specific problems. But I'm going to do all 50. It'll probably take me about 2 hours. Here I go. So problem number one, simplify each algebraic expression. Let's begin with the one on the left. So I see it, and I'm going to immediately distribute the things that I can. And so 3 times 4y is 12y. 3 times negative 4 is negative 12. And then I have to distribute this minus sign, right? That's like distributing negative 1 times 8y. So I get a negative 8y. And then negative 1 times positive 1, which is negative 1. Great. Now I'm going to combine like terms. I see terms with y in them, like 12y minus 8y. That combines together to make 4y. And then negative 12 minus 1 is a negative 13. So my simplified result is 4y minus 13. I'll try this one on the right. So looking at it, I'm going to address this little by little. First, I'm going to distribute this minus sign into both of these terms. It flips the signs, right? So I write 3 minus 3 times 3 minus 2y plus 2. And that's now what I have. Now I see these constants, and I can combine them together. 3 plus 2 is 5. So I can rewrite this as 3 minus 3 times 5 minus 2y. At this point, that's when I would distribute this 3 into both of these terms. And I now have 3 minus 15 minus, well, plus 6y. Right, why is it positive 6y? Because negative 3 times negative 2y is positive 6y. Please be careful with that minus sign right there. I'm distributing it in with the 3. That's negative 3 times 5, negative 15. Negative 3 times negative 2y, positive 6y. And now combining any like terms, like 3 minus 15, that gives me a negative 12. And then I have the plus 6y. That's my answer. Sometimes we like to write the term with the variable first, which is positive 6y, and then the constant second. So I'll write my answer as 6y minus 12, but negative 12 plus 6y is also the correct answer. Let's move on to problem number 2. We're moving from simplifying algebraic expressions to now solving linear equations. So let's solve this linear equation for x. And to get started, we'll just subtract 4. So I'm going to subtract 4 from left to right. Rewriting the equation, I have negative 5x equals negative 11 minus 4, which is negative 15. I now divide by negative 5 across the equation. And I have solved for x. I found that x equals negative 15 divided by negative 5, which is positive 3. Yes, because a negative divided by a negative is definitely a positive result. And so I write my solution, x equals 3. I'm ready to move on to problem number 3, where I will solve another linear equation for x. And this one is more developed. So I have more things to do. Let me begin with distributing. Rewriting this equation after distribution, I have 6x plus 42 plus 4 equals negative 6x. Oh, by the way, this is not 42, it's 48. 6 times 8 is 48. Cool, fixing it up. Negative 6 times negative 3 is positive 18, and then I have a minus 2. Now, there are constants that can be combined together on both sides of the equation. Like here, I have 48 plus 4, and here I have 18 minus 2. So let's clean up those constants. And I have 6x plus 52 equals negative 6x, and then plus 16. So now I'm going to move all my terms with x to one side and all my constants to the other side, because that is the strategy for solving linear equations. Yeah, so here I'm going to add 6x from right to left, and I'm going to subtract 52 from left to right. There I go. And 6x plus 6x is 12x. And that's equal to, well, 16 minus 52, which is negative 36. And now I'll divide by 12, and I'm done. X is equal to negative 36 divided by 12, which is negative 3. So I'll write my answer right here. X equals negative 3. There we go. We're ready to move on to problem number 4. So a painting is on sale with 40% off. Its current price is $390. What was the painting's original price? Now, the easiest way for you to get this done is to take that 390 current price and divide by the percent that its value is currently. So if it's 40% off, then it's valued currently at 60% of its original price. Let me help you with that. Like 1 minus, I'll do that over here, 1 minus 40%, which is 0.40, equals 0.60. And that's what I'm going to divide by. I'm dividing by 0.60. So hopping on a calculator, I quickly type, like 390 divided by 0.6, and I get my answer. The original value was $650 before it went on sale. There you go. So that's the painting's original price. We're ready to move on to problem number 5. And here in problem number 5, we have a word problem. Sebastian drives 50 miles per hour. Teresa drives 41 miles per hour. They started at the same spot and drove in opposite directions. After some time, they were 1,856.4 miles apart. How much time has passed? Now, I am always going to create like a table chart like this so that I can organize my information. I highly recommend that you do. Now, we're talking about a distance equals rate times time problem, right? Often called a dirt problem because DRT, dirt. Okay, and so distance is equal to rate times time. That's kind of where we're starting. And we've got two people that we're talking about. We've got Sebastian and we've got Teresa. All right, and we know their speeds. And a speed is a rate, right? 50 miles per hour. That's the rate with which Sebastian is traveling. So I'm going to input 50. And Teresa, well, she drives 41 miles per hour. Now, they're starting in the same location and going in opposite directions, right? So after some time, that's the thing we don't know. And I can call, that any variable I want to. For time, oftentimes we use the letter T for time. Okay, and after that amount of time that we don't know, they were 1,856.4 miles apart. So I'm going to put my grand total right here. Okay, and I know that if I take, the rate times the time, that will give me the distance for Sebastian. So that's 50t. And then the rate times the time for Teresa is 41t. I can now take this column that I've created right here and create an equation with it, saying that if I take 50 times t plus 41 times t, that will equal the total distance of 1,856.4. So I'll create an equation with it here on the side and say 50t plus 41t is equal to the grand total 1,856.4. Now, I see these are like terms that I can add together, right? The 50t plus the 41t, and that gives me 91t. Okay, and now I can divide the 91 from the left side to the right side to solve for the time t. I'm trying to get the variable t all by itself, and I, simply take 1,856.4, their total distance apart from each other, and I'm dividing it by 91. And I find, well, that's 20.4. So I have found the answer. It takes them 20.4 hours to get that far apart from each other. I mean, yeah, like that's a pretty big distance. They're almost 2,000 miles apart from each other, going 50 miles per hour and 41 miles per hour respectively. So it took 20.4 hours. After that many hours, Sebastian and Teresa were 1,856.4 miles apart. And now we're ready to move to problem number 6. Solve for x. Negative 3 times x minus 2 minus 23 equals negative 4 times x plus 3. And yes, since we have a lot of instances of the variable x, we're going to distribute here. And I get negative 3 times x plus 6 minus 23 equals negative 4 times x minus 12 once I distribute. And now I'm going to combine maybe like terms on the same side of the equation. I see constants like 6 minus 23, which gives me a negative 17, right? So I could clean things up a little bit, just adding these constants together, getting negative 17. Now I want to get all my terms with x on one side and all the constants on the other, because that's how we solve linear equations. That's one strategy for getting it done. So I'm going to add 4x from right to left, add 17 from left to right. Now I observe that I've got on the left side of the equation, well, negative 3x plus 4x, which is 1x, and negative 12 plus 17, which is 5. And surprisingly, I have now solved for x. It's all done. I found out x equals 5. That's my solution. Moving on to problem number 7. Now let's talk about graphing linear equations like we did back in chapter 3. Choose the graph of the equation y equals 5/7 x plus 3 in the coordinate system. Complete the table to find 2 points on that line. Now, you're the one that gets to decide the x values that you're going to choose for this table, and then we'll find the y values by plugging the x values into the equation. Now, one great x value to choose is 0, but you're welcome to choose any x value you want to. You might just get ugly fractions if you pick some poor ones. And so I'm going to pick an x value of 0. Why would I do that? Because y equals 5/7 times 0. Plug that 0 in for x right there, right? Plus 3. And what is the y output there? Well, 5/7 times 0 cancels. And so I just get the y value of 3. Okay? So why did I pick 0? Because that caused this fraction to disappear, right? 5/7 times 0 cancels. It's just 0 plus 3. Great. Now, the ordered pair is an xy coordinate. That's what an ordered pair is. So I take the x value and the y value, put them in parentheses, separated by a comma, and that's the ordered pair in question. Now, I'm going to pick another x value, and a really good x value to choose, just so you end up with an integer answer, would be the denominator of the fraction. So I'm going to pick the x value of 7. Okay, that's what I'm going to choose. You're welcome to choose anything you want. So I get 5/7 times 7 plus 3. And why is that such a good idea? Because the denominator of 7 cancels the multiplication of 7, and now I just get 5 plus 3, which is 8. All right, so I found my output, right? My y value output is 8. So my ordered pair is 7, 8. Now, as you look to decide which graph is correct, please pay attention to the scaling of the x and y axis. Like the y-axis is scaled 1 unit at a time, like 1, 2, 3, 4, 5, 6, 7, 8. But the x-axis is scaled 2 units at a time. It's starting here and going 2, 4, 6, 8, 10, 12. So the scaling is slightly different. Please note that. Now, I'm going to look for the graph that has my 2 points on it that I chose, 0, 3. This graph has 0, 3. So does this one. So does this one. So does this one. So all of them have 0, 3. But the one that will make the correct choice for the graph stick out is this point, 7, 8. And so I go to a location of 7 on the x-axis and up to a height of 8 on the y-axis. And I notice, nope, that graph doesn't touch. Now I'll do it for graph B. I go to an x value of 7 and a y value of 8, and look at that. That's exactly where that graph crosses through. I do it again for this one, and nope, doesn't quite do it. And try it again for this one, 7, 8. Nope, graph doesn't go through it. So the correct choice for the graph, in my case, is graph B. Awesome. Let's move on to problem number 8. Choose the graph of the equation x equals 5 in the coordinate system. Complete the table to find 2 points on that line. Little reminder for you. When y equals a number, that's a horizontal line. When x equals a constant number, that's a vertical line. Okay, so when I see x equals 5, no matter what y value I have, x is guaranteed to be 5. Yeah, we don't even see y in this equation. So that's a vertical line at an x value of 5. On my graph, I go to an x value of 5, and it creates that vertical line. This is the correct choice, option B. Now, when you pick some points, your x values have to be 5, right? So I have an x value of 5 here and an x value of 5 here that I'm choosing. Why? Because x is guaranteed to always be 5 in this equation. And I could pick any y values that I want to. I could pick 0 for the y value, or I could pick negative 7 for the y value. It doesn't matter, right? I could pick 1 and 3 because those points will definitely be on the graph. Look, if I go to a value of 5 comma 1 and 5 comma 3, they'll both be on that graph of that vertical line. Make sense? Great. So you can choose any y values, but your x values both have to be x in this case. And so the ordered pair is 5 comma 1 and 5 comma 3 that I've chosen. I've chosen that. Great. We're ready to move forward to problem number 9, which states to find the y-intercept and x-intercept of the line given by the equation 8x plus 7y equals negative 56. Now, a little reminder to find x-intercepts and y-intercepts. Let me help you here. Well, to find a y-intercept, let x equal 0, and then you'll solve for y. Okay. Now, for an x-intercept, I'll set that up over on the right side, we let the opposite variable, y, equal 0, and then solve for x. Cool? So if I already start to fill out this table right here, for a y-intercept, the x value is 0. For a y-intercept, the x value is 0. And then for an x-intercept, the y value is 0, because I let y equal 0 in that case. There we go. Now, we're actually going to plug these values into the stated equation. Okay, so working on that y-intercept, I turn x right here into 0. Rewriting this, I have 8 times 0 plus 7 times y equals negative 56. And yeah, that 8 times 0, it cancels. And I now divide, let me do this in red, I divide by 7 from left to right. And I find out that y is equal to negative 56 divided by 7, which is negative 8. All right. So I have found the y value in my y-intercept. So I go to the y-intercept, its y value, I input negative 8. And then I can write the location as an ordered pair. So that's x is 0, y is negative 8. Okay, we finished the y-intercept information. Let's move over to the x-intercept on the right side here. So I'm going to let y equal 0. I go to this y, turn it into 0, rewriting everything. I have 8x plus 7 times 0 equals negative 56. Great. So yeah, 7 times 0 is just 0. And I'm now going to divide 8 in red from left to right. And x equals negative 56 divided by 8, which is negative 7. Done. All right. So I'm going to the x value of the x-intercept, and I input negative 7. My y value is 0, so the location is negative 7, comma 0. Done. We have found the x and y intercepts of this linear equation. In fact, this is how you can find x and y intercepts for any given equation ever, right? You can let x equal to 0 to get the y-intercept and let y equal 0 to get the x-intercept. That's always how it's done, always. Great, moving on to problem number 10. What is the slope of the line through 6 comma negative 6 and 6 comma negative 3? Now, for all three of these pieces that we're about to do, there is the slope formula, right? They're asking about the slope. And the slope formula takes 2 points. And it takes the y values and subtracts 1 from the other. And then it takes the x values and subtracts 1 from the other. Okay, so if I label these points like x1 comma y1 for the first point and x2 comma y2 for the second point, that'll all make sense now. Cool. So I'm taking the difference of the y values divided by the difference of the x values. Be careful, order matters. So I'm going to pick y2. What did I call y2? Negative 3. Okay. So I'm starting with negative 3. And then I have the minus sign of the formula. Okay, and then I look at what y1 is. y1 is negative 6, so I write negative 6. Great. Now I move to the bottom, x2 minus x1. Well, x2 is 6, x1 is 6, So I'm taking 6 and subtracting 6, like that. Now, whenever you have a double negative, like you do in this case, the negative of the formula, right, the minus sign of the formula here, and the negative value of y1, then you have to turn that double negation into a plus sign. Just make that a big plus sign. Continue forward. Negative 3 plus 6 is 3, and 6 minus 6 is 0. And now remember, dividing by 0, when 0 is in the denominator, that is an undefined slope. Okay? It is always undefined when we divide by 0. So that's what we write as our answer. And looking back, we could tell that the slope would be undefined because the x values were the same. When you have the same x value, then you will have an undefined slope because that creates a vertical line. Okay? Moving on. What's the slope of the line through 1 comma negative 10 and 7 comma negative 10? So I'm going to take that slope formula that we just wrote down, and I'm going to have a little fun just copying and pasting it. There we go. Because we're going to use it 2 more times. And so, well, y2 minus y1 for this case is negative 10 minus negative 10. So I'll write that out. Negative 10 minus negative 10. And then x2 minus x1, that's 7 minus 1, like that. Now, I see a double negation, so I'm going to turn those two minus signs into a big plus sign and continue. Negative 10 plus 10 is 0, and that's divided by 7 minus 1, which is 6. So my slope is 0 divided by 6. Now, when you have 0 in a numerator, well, that's just 0. Okay, so that's the answer. The slope of the line that passes through these 2 points is a slope of 0. Now, what type of a line has a slope of 0? That's a horizontal line. And a horizontal line happens when the y values are the same. Look, my y value is the same for both points. That's why I know that my slope is 0 and I'm correct. Moving on to the third part of this problem. So I'm going to take these 2 points, 9 comma negative 1 and 6 comma negative 6, plug them in, and I get negative 6 minus negative 1 on top. Please remember your y's, they always go on top, and your x's go on the bottom because y's are the rise and x's are the runs. Yeah. And now take the x values, 6 minus 9. Okay. And so now cleaning things up, I see a double negation here up top. Negative 6 plus 1, that gives me a negative 5. And then I'm dividing that by 6 minus 9, which is negative 3. And please remember, if you have a negative divided by a negative, it's a positive. Just like when you take a negative times a negative, making it a positive, it's the same thing for division. So I'm going to just make those disappear, right? I can just like disappear those negatives, and I have a slope of 5/3. That is my final result. Okay, that slope is 5/3. All right, let's go ahead and proceed forward into problem number 11. Here it is. The equation of the line that goes through the points negative 2 comma negative 7 and 8 comma 10 can be written in the form y equals mx plus b, where its slope m is what? And once again, they're asking me what is the slope of the line that passes through these 2 points. So I get out the slope formula one more time in this review. Okay, remember, y's are the rise, they go on top. X's are the run, they go on bottom. Rise over run is what a slope is. And so I take y2, the second y value, minus the first y value. Okay, so 10 minus negative 7. And I divide it by the second x value minus the first x value. So that's 8 minus negative 2. All right. So you see how careful you need to be with signs. And both cases, on top and bottom, I can turn those double negatives into a positive, and 10 plus 7 is 17, and 8 plus 2 is 10. I have found that my slope is 17/10. We did it. All right, moving on to problem number 12. Solve the following system of equations using whichever method you wish. In this course, you have learned the substitution method. You have learned the elimination method. You have learned to solve by graphing. You get to choose what you want to do, but in this case, oftentimes there's an easier method, and in this case, I would use the elimination method. In fact, I'm going to try to eliminate the x's. To do it, I need to multiply the top equation by 4. And so that's what I do. I'm going to take this top equation and then just multiply it by 4. Okay. And I'm going to rewrite the top equation, distributing 4. I get negative 4 times x plus, 4 times 5y, which is 20y, equals 4 times 28, which is 112. And I'm going to rewrite that bottom equation, the second equation, exactly how it is, 4x plus 6y equals 18. And I'm going to perform stacked addition of these two equations. Because when I add negative 4x plus 4x, that's 0x, and the x variable is eliminated. That's why this is called the elimination method, because we can eliminate one of the variables, which is great because that helps us solve for the other variable really fast. And so I can take 20y plus 6y to get 26y, and then 112 plus 18 gives me 130. Okay, so I got 130 there. All right, so my resulting equation that I currently have is 26y is equal to 130. And if I quickly divide by 26, I'll have solved for y. So I find out, yeah, y equals 130 divided by 26. I think it comes out to 5. Let me make sure. Okay, I'm just taking 130, dividing it by 26. Oh, yep, the answer is y equals 5. Now I'm going to take that, and I need to find x, right? Because we're trying to solve this system for both variables, the x variable and the y variable. And it doesn't matter if you use the top equation originally before we multiplied on 4 or the bottom equation. I'll just choose the bottom equation for fun. I have 4x plus 6y. Now, y, I just found it's 5. So I'm going to replace y with 5. And that equals 18. And now I have an equation that I can solve for x. In fact, this is 6 times 5, which is 30. And so I'm going to subtract the constant 30 from the left side to the right side. And now I have 4x equals 18 minus 30, which is negative 12. Next, I'm going to divide by 4. And I find out that x equals negative 3. Negative 12 divided by 4 is negative 3. There you go. So I have found an x value and a y value. And when I write my answer, I type it as an ordered pair, an xy coordinate. So I create parentheses with a comma. I put the x value first and the y value second. And that's how I report my answer. Negative 3, comma 5 in parentheses, separated by a comma. That's an ordered pair. Great. Problem number 13. Here it is. You poured some 8% alcohol solution and some 6% alcohol solution into a mixing container. Now you have 800 grams of 6.8% alcohol solution. How many grams of 8% solution and how many grams of 6% solution did you pour in? Write and solve a system of equations to answer. Now, to organize my information, I created a table. It looks like this. And I welcome you to create a table to organize your information when you test. Now, I see that I have, some 8% solution, some 6% solution, and they're going to be mixed together to make a 6.8% solution. Those are the types of solutions that I have. Now, the concentration, see, that is the same value as these types I have. So, this concentration is 8%, this one's 6%, this one's 6.8%. Some people say, should you write them as a decimal or should you keep them integers like this? And the answer is, it would work either way. If you turned 8% into 0.08, 6% into 0.06, and 6.8% into 0.068. But it's easier just to keep them as integers. It'll be easier on your brain instead of worrying about decimals. Great. Now, let's address the number of units for each of these solutions. I was told that I will have, when I combine everything together, 800 grams of that 6.8% alcohol solution. So that's why I'm putting 800 right here. Okay, so I have 800 grams of the 6.8% solution. What I don't know, and I'm going to find out in this process, is how many grams of 8% solution and how many grams of 6% solution I have. But I do know that they will add to make 800. And so this is where I'm going to pick some variables. And I can call, this 8% solution's number of units X. I don't know how many there are, how many grams, but I'll call it X. And I know X plus this number has to make 800. In other words, if I take 800 and I subtract X, it will give me this. So being clever, you guys are clever students, you're going to take 800 minus X and put it right there. Because 800, the grand total, minus X is how much this is. Okay, so now I have an expression. Now, if I take the number of units times the concentration, that gives me the total amount. And so I can multiply these pieces together, like X and 8, to get 8X. And then I multiply 800 minus X times 6. Some people like to write that 6 first, so 6 times 800 minus X, like that. And then I can multiply the 800 times 6.8 together. So I'll just keep it like that right now. 6.8 times 800. Okay? Where this is a decimal and this is the multiplication symbol. Great. Now, what's awesome in me organizing all this information is that I now have this column that I can create an equation with. Okay? So what I can do is I could take the top piece and add it with the middle piece and set it equal to the grand total. Yeah. So take the top row, add the middle row, set it equal to the bottom row. That's the equation that we can use to solve this problem. And so I'm going to write it here. I'm going to say 8x plus 6 times 800 minus x. That's got to be equal to 6.8 times 800, like that. Now I can start to solve this equation that I built. Okay, so that's the next step, is for you to solve the equation that you create. And I'm going to distribute this in right there, that's 6, and I get 8x plus, well, 6 times 800 is 4,800, and then minus a 6x, and that equals whatever 6.8 times 800 is. Oh yeah, it's 5,440. Great. So now I've cleaned up my equation to this point here. And I see this is a linear equation. And I can solve this linear equation for the variable x. I can combine these like terms here and here. I can subtract this constant to the other side. So I'll get that stuff done right now. I'm subtracting 4,800 from left to right. I'm combining 8x minus 6x, which gives me 2x. Okay. And I find 2x is equal to, well, 640. Great. And now you're like, okay, well, solving is easy at this point because all I have to do is divide by 2, right? And I find out x equals 640 divided by 2, which is 320. All right. Now that's grams of, what did I say x was? I go back to the organized table I built. Well, x represented the number of grams of 8% solution, right? Great. And so I can start answering my question, or I can go through the answer. You mixed blank grams of 8% solution. Well, yeah, that was 320 grams. And then how many grams of 6% solution do I have? I need to go back and I need to say, well, that's 800 minus x, which is x is 320. So I could just take 800 minus 320, and I find the answer is 480 grams. And that's 480 grams of that 6% solution. Please be careful. Do not mix these up, right? It's definitely 320 grams of 8% solution and 480 grams of 6% solution, not the other way around. So be very careful as you answer your problem here. Don't mix them up. Here we go. We're moving on to problem number 14, which states, evaluate x to the 6 times x to the third equals x to the n for n equals something. What does n, the exponent n, equal? Well, let's find out. Now, in this course, you have learned 8 exponent rules. So this problem is testing one of your exponent rule knowledges, okay, and that is the product rule, okay? So when I multiply the same base to different powers, I can take that base and add their powers together. Okay, so x to the 6 plus 3 power. And cleaning that up, I get x to the 9th, right? 6 plus 3 is 9. And so I found my answer. X to the n is x to the 9th. So n must be 9. And that's how I'll report it. N equals 9, that exponent that I found. Awesome. Moving forward, problem number 15 says write the following number in decimal notation without using exponents. All right, so we worked on scientific notation in this course, making sure that you were good with scientific notation for future science classes. And so this is written in scientific notation. We want to put it in decimal notation. And this 10 to the negative 3 power is, that scientific notation. That negative 3 tells me that this number is actually smaller. Okay, so I move the decimal 3 places to the left. However many the exponent is, that's how many decimals I'm going to move to the left, okay, to get that smaller number. Now, if this was a positive exponent, I would be moving the decimal to the right in this case. So think critically about, am I dealing with a smaller number or a bigger number? Anyway, I end up moving the decimal place 1, 2, 3 places to the left. Okay, 3 places to the left. And I fill in the empty spaces with zeros. And that's my answer. So my solution is 0.0093. That is the answer to this. Cool. So we just wrote something in scientific notation in decimal notation. Let's continue forward and let's begin talking about our skills from polynomials in chapter 5. Okay, so when I see a binomial squared, right, 8x plus 7 squared, the definition of squaring something is multiplying that thing by itself. What you'll want to do immediately is write 8x plus 7 times itself. Great. Now FOIL, right? The problem tells you what to do. It says FOIL. So that's multiplication of first terms, outer terms, inner terms, and last terms. So 8x times 8x gives me 64x squared. Then 8x times 7 gives me a 56x. Now inner terms, 7 times 8x, well, that's another 56x. And then last terms multiplied together, 7 times 7, that gives me a positive 49. And combining any like terms, I get 64x squared plus 112x plus 49. What I just did was add 56x plus 56x to make 112x. Now that I've combined all like terms, I can report my answer. This is my solution. Problem 17, perform the indicated division of a polynomial by a monomial. All right. When I take a polynomial like this binomial divided by a monomial, I take one term at a time out of the top and divide out that bottom piece. So let's start with the first term, 14x squared, and divide 7x squared. Sorry, 14x to the fourth and divide 7x squared. So 14 divided by 7 is 2. And x to the fourth divided by x squared is x squared. You could use the quotient rule of exponents, right? I just took 4 minus 2 to get 2. That's the quotient rule of exponents that I was just using. Now I see the minus sign. of the numerator. So I put that minus sign. Now I'm going to take 28 and divide it by 7 to get 4. And I'm going to take x squared and divide it by x squared to get, well, no x's, because 2 minus 2 is 0. So there are 0 x's now, and so that becomes invisible. That's the answer right there. 2x squared minus 4. Great. So when you take a polynomial and divide by a monomial, just take it a term at a time, dividing out what you can. Problem number 18, factor the given polynomial r squared plus 13r plus 42. Yeah, this is a trinomial, and I'm going to try to factor it into two binomials. By the way, if it doesn't factor, we would say that it's prime. Okay, if it's not factorable, we say that trinomial is prime, that polynomial is prime. Okay, but in this case it is factorable. I'll show you why. So we create two binomials and we put r at the beginning of each one, right? Because r times r is r squared. Now we look at the constant and we find all of its possible factors. Okay, it's important that you find all possible factors, not just some of them. So if I see 42, I turn it into 1 times 42, 2 times 21, 3 times 14, and then 6 times 7. These are all of the possible factors. If you miss one of the possible factors, you might struggle to finish off the factoring. Now, I now look at my options. There are 4 sets of options, but I need the option that will make the middle value. They will add to make the middle value of 13. And so 1 and 42 don't add together to make 13. And 2 and 21 do not add together to make 13. And 3 and 14 cannot add together to make 13. And I'm down to my last option. And it works because 6 plus 7 is 13. Okay? So I put a plus 6 and a plus 7. It doesn't matter in this case the order with which you do it. You could put the plus 7 first and the plus 6 second, right? And both my factors in this case were positive because of this plus plus situation I'm dealing with. But there you go. We just factored this trinomial. Problem number 19, factor this trinomial, 3x squared plus 10x plus 3. In this course's lessons, you learned that when the a value is greater than 1, right? Here the a value was 1. Here the a value is greater than 1. Then what you do is you either try trial and error or the AC method. Careful, if you choose the AC method, you would then have to go factor by grouping. You'd have to know the skill of factoring by grouping. So I'm just going to do trial and error with you here. Now, in trial and error, we take the A value and we find its set of factors, and we take the C value and find its set of factors. And luckily, the set of factors for the value 3, the A value, is just 1 and 3. And for the C value, also it's just 1 and 3 because 3 is a prime number. So sometimes trial and error will be very easy because we're dealing with prime numbers for the A and C values. In this case, that's true. So I set up my two binomials and I put a 1x and a 3x. These are the coefficients that go with x. All right, I'm going to put the 3x first and the 1x second because sometimes students like to have that larger coefficient in the first binomial and the smaller coefficient in the second one, but it really doesn't matter at this point. But what does matter is what you decide next. You see, these spots, they get the C values factors, which are 1 and 3. So it could be a 1 here and a 3 here, or vice versa, a 3 here and a 1 here. How do you know which one? You would have to imagine the outer and inner terms of foiling. When you add them together, they need to make this middle value 10. Okay, this 10x. Okay, so let me show you the wrong way. And by the way, this is trial and error. So if I decide to put a plus 3 right here and a plus 1 right here, yeah, my 1 and my 3, I put my 1 there, 3 there. Well, I would multiply the outer and inner terms of foiling, like 3x and 1. When I multiply them together, that gives me a 3x. And then I take 3 and I multiply it with x, and that gives me a 3x. And I add them together, right? 3x plus 3x, and that gives me 6x, which is not what I want. I want a 10x to result. And so I go back and I say, okay, well, that was just a trial. What if I switch? So I put the plus 1 here, and then the plus 3 goes here. And I try it again, and I say, okay, the outer and inner terms of FOILing will be, well, 3x times 3, which is 9x. And then a 1x, is here. 1 times x is just 1x. And if I take 1x plus 9x, that gives me 10x, which is exactly what I wanted, a positive 10x. So this now I've done it. The trial and error method is over, so I will write my final answer as plus 1 and plus 3 here and here. Okay, so final answer, 3x plus 1 times x plus 3. That's it. Moving on to problem number 20. Factor the given polynomial t cubed plus 343. Now, 343 is a perfect cube, but in case you don't remember that, well, here's a hint. 343 equals 7 cubed, right? So this is t cubed plus 7 cubed. And when I see that, I think of the sum of cubes pattern. Now, this is on your formula sheet for testing purposes, so you have access to that formula sheet. And so you would set it up as a binomial multiplied by a trinomial. Okay, so here I created space for a binomial, here I created space for a trinomial. Let's talk about what goes in the binomial. I get a t and a 7, the bases of the cube, right? T and 7. That's what I write, t, 7. Now, I take the first term and I square it. Okay, just take that first term, t, and square it to begin writing the trinomial. For the second term, we take t and multiply it by 7. Just take these two things in the binomial, multiply them together, and I get 7t. And for the third term of this trinomial, it goes here. Just take the second term of the binomial and square it. 7 squared is 49. 7 squared. Great. So we now have all the terms of the factored version of the sum of cubes. Now I need the signs. And I waited until the end to talk about the signs. We use an acronym called SOAP. And that acronym means same, opposite, always positive. Let me show you what I mean. I look at the sign between the perfect cubes and it's a plus sign. So I'm going to keep the same sign for S. It goes right there. And opposite sign of plus is negative, right? Minus sign. So same as what I had, opposite, and then this one's always positive. All right, same, opposite, always positive. Same, opposite, always positive as this thing. Now, careful, you also have a difference of cubes pattern where you would have subtraction instead of addition between the perfect cubes. All right, but we'll leave it at that for now. Great job. You just factored the sum of cubes. Moving on to problem number 21. It says use factoring to solve the polynomial equation 4x squared equals 4x minus 1. Now, to factor this polynomial equation, this quadratic equation, I need to set it equal to 0. So I will set it equal to 0 by subtracting 4x from right to left and then adding 1 from right to left. So I've grouped all of my terms on the left-hand side of this equation, and I have 4x squared minus 4x plus 1 equals 0. All right? At this point, I'm going to factor this resulting trinomial. And this trinomial has an a value greater than 1. And so I will list the factors of the a value, 1 and 4 and 2 and 2. And I will list the factors of the c value, which are just 1 and 1. Oh, that makes me really happy. The c value is 1. 1 times 1 is the only set of factors. Now, I'm going to create two binomials. And in those binomials, well, because I know this is a minus plus situation, I know that both those ones that I wrote as factors are negative, right? I look at the scenario. This is a minus plus situation. The only way that could be possible is if both of these ones are negative. And so I already know something about this. I know that I have minus ones here and here, right? This set of factors goes here and here. And now I need to decide with trial and error, am I going to use 1 and 4 to go with x, the coefficients of x, or am I going to use 2 and 2? And so maybe I run a little trial and error really fast, and I decide, hey, what if I put a 4 and a 1 here and here? Will that work? Well, I have to think of my outer and inner terms of FOILing and see if they make negative 4x. So let's see, 4x times negative 1 is a negative 4x. And then a negative 1 times a 1x is a negative x. And negative x plus negative 4x equals negative 5x. And dang, no, it didn't work because I needed it to be a negative 4x. I got a negative 5x. Okay, well, that didn't work. So I'm going to cross out the 1 and the 4, and now I'm going to try the 2 and the 2, right? I put a 2 there and a 2 there, and I ask myself, will it work now? And I think outer terms will make 2x times negative 1, negative 2x. And inner terms, negative 1 times 2x makes negative 2x. And if I add negative 2x plus negative 2x, that equals negative 4x, which is exactly what I want. Okay, my trial and error is done. I did it, right? And so, yeah, I set that in stone. I say, well, yes, it's confirmed. I've got 2x minus 1 times 2x minus 1 equals 0. Now, to finish, this is an equation. I just factored the trinomial. It's set equal to 0. Now I can use the zero product property. And the zero product property says I could take each piece and set each piece equal to 0 and solve each one for x. So I take each factor, 2x minus 1, set it equal to 0. 2x minus 1, set it equal to 0. And then go through the process of adding 1. Right? I'm going to add 1. I'll do it in both cases. And then I get 2x equals 1, 2x equals 1. Now I divide by 2. All right. I found out that x equals 1/2. Twice. I got 1/2 2 times. Now, if you get the same answer twice to a quadratic, you only have to report that same answer 1 time. So I'm going to just get rid of that extra comma with that extra 1/2. It was the same value, so I only have to report that 1 time. So that's my final answer. X equals 1/2. Great job. Moving on, problem number 22. Simplify the rational expression x squared plus 8x plus 15 divided by x squared minus 9. This is where you really show off your factoring skills. So when I see this rational expression, and by the way, rational means it's a fraction, right? It creates a ratio. Okay, I'm going to factor the top trinomial, so I'll factor it into 2 binomials like this. And then I'll factor the bottom. Let's worry about the top first. And so I think for a second, can you think of 2 numbers that multiply to make 15, but sum to make 8? And you would think, and you would say, well, 5 and 3. So that's what we'll write right now, 5 and 3. So we have now factored this trinomial into 2 linear binomials. And now looking at the bottom, x squared minus 9, I see the difference of squares. We've addressed this multiple times. The difference of squares is, you'll see it clearly here. Difference means subtraction, and that's of 2 things that are squared. Your brain's gonna have to turn 9 into 3 squared. And then you'll remember that the difference of squares when you factor it will factor into like x and 3 and x and 3 with opposite signs between them. A plus in one and a minus in the other. It doesn't matter the order with which you put the plus and minus. Okay, so the difference of squares factors into the product of conjugates. And this has been addressed in like 3 or 4 different lessons. Okay, and why did I just factor everything that I could because now we can cancel factors that are in common on top and bottom of this fraction. In fact, I see an x plus 3 on top and an x plus 3 on the bottom. Those are exactly the same factor, so they can cancel. And so what remains on top is an x plus 5, and what remains on bottom is an x minus 3, and that's the result. The answer is x plus 5 divided by x minus 3. And you may be tempted at this point to cancel like x on top and x on bottom. You cannot do that. You cannot cancel terms. You can only cancel factors. Okay, so if you try to cancel terms, that's when kittens die, right? You kill kittens when you cancel terms instead of factors like we addressed in the past. Great. So we're happy with this. No kittens killed. X plus 5 divided by x minus 3. And now we're ready to move on to problem number 23. Perform the indicated operation and simplify. Assume any factors you cancel are not 0. And I see this rational expression divided by this rational expression. Now, when you take a fraction divided by a fraction, you keep it, switch it, flip it. And so I'll just say that down below. Like or up above, keep, switch, flip. This will be a great reminder. Okay, now as I keep switch flip, I'm also going to factor everything that I can. All right, so I'm setting up for success. And I'm going to factor top left, bottom left, top right, and bottom right as I flip that. Okay, so looking at 2x minus 8, it has a GCF of 2. And I'm left with x minus 4. Okay, that's factored. Bottom, when I see 9x minus 27, I factor out the GCF of 9, and I'm left with an x minus 3. Cool. Now, I'm switching division into multiplication by taking the reciprocal of the second fraction. So I'm going to take this stuff on bottom and factor it to write it on top. Okay, so factoring x squared minus 6x plus 9. And I think for a second, and I say, well, that's going to be x minus 3 times x minus 3. All right? So I thought of two numbers that multiplied to 9, but summed to negative 6. And those two numbers were negative 3 and negative 3. Now, looking at the top, I think for a second, and I say, well, x squared minus 8x plus 16. Well, it factors to x minus 4 times x minus 4. Right? Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. That's why I'm making those decisions. And now, I look at the factored version after I did a keep switch flip, and I get out my canceling pen to see if any factors cancel. And in fact, they do. Look at this. I have an x minus 4 factor with an x minus 4 factor on top and bottom. And also an x minus 3 factor that cancels an x minus 3 factor on top and bottom. So that was everything that I was able to cancel. And so I write my final result as a single fraction with the remaining factors. On top I have 2 and x minus 3. And on bottom I have 9 and x minus 4. And nothing else reduces. And this is as far as it goes. And if you try to go further, something bad happens to a kitten. Problem number 24. It says simplify the expression 2x minus 5 over x minus 2 plus 5 minus x over x minus 2. And I see that I have addition between these two fractions, these two rational expressions. But what's nice is the two denominators are the same. So always look at the denominators of these rational expressions. If they're the same, your life is very easy because you're just going to have the same denominator matching the other ones, right? X minus 2 is the common denominator. And in the numerator, we're going to perform all of the operations that we see, combining any like terms. Okay, so I'll make this easy for you to see it. I have a 2x minus 5, yeah, 2x minus 5, plus 5 minus x. So I can write that out, plus 5 minus x. Okay, now always ignore the denominator once you have that common denominator. You're not even gonna think about doing anything to it. It's just staying the same, x minus 2. But that top, look, negative 5 plus 5, those cancel each other. Boom, boom. And 2x minus 1x, those are like terms. 2x minus 1x is just 1x. And this is my answer. This is the result. Now, the way we report our answer in this case is give your answer in the form f of x over g of x, saying what is the stuff on the top? Well, that was x, right? So my answer for the numerator was just x, okay? And then what was the answer for the denominator stuff? Well, that was x minus 2. And definitely do not try to cancel x with x on top and bottom. Do not do that, okay? Wow. Okay, I just saved you. Here we go. Problem number 25. Simplify the expression 1 over x plus 5 minus 1 over x plus 8. And how is this more complicated than the last one? Because the denominators are not the same. All right? So when the denominators are not the same, we need to find an LCD, a least common denominator. In fact, what I would do if I were you for this problem is I would say, well, I've got x plus 5, but I'm missing the other denominator, x plus 8. And so I multiply the missing factor on top and bottom of the first fraction. And then in the second fraction, I have an x plus 8, but I'm missing an x plus 5. So I'm going to multiply an x plus 5 on top and bottom of the second fraction. Great. And so now I have a common denominator. So I created a common denominator, x plus 8 times x plus 5. That's the same denominator for both fractions now. And now let's look at our numerator stuff. So I'm going to have to think of like distribution. In this case, multiplying 1 into x and 8, right? I get a 1x plus an 8. Now here's where you have to be very careful. See the minus sign, right? We're subtracting these rational expressions. So this minus sign has to distribute with the 1, right? This is negative 1 times x and negative 1 times 5. So I'll be very explicit here by distributing that negative 1 into both those terms. So I get a minus x and a minus 5. To finish, all I do is combine any like terms. Okay? So combining like terms here in my numerator. By the way, I'm ignoring my denominator now that I, found a common denominator. It just stays the same. Nothing changes. Just stays there. But my numerator, see, it simplifies further. X minus x, those cancel, right? 1x minus 1x, fight and die. Whom. No kittens killed. And 8 minus 5 is 3. So that's my numerator. That's my result. Okay? So it says give your answer in the form of f of x over g of x, where f of x is just the top of that fraction answer. So I'm going to report 3. And what is the denominator, right? G of x. What's that denominator? Well, it's x plus 8 times x plus 5. Right? So really this is just asking what was the result of your numerator? 3. What was the result of your denominator? X plus 8 times x plus 5. Cool. So here I go, problem number 26. Perform the indicated operation and simplify. Assume any factors you cancel are not 0. So the way this is set up right now, we have negative 1 powers, right? B to the negative 1 power minus 1 divided by 1 plus b to the negative 1 power. A negative exponent is the reciprocal of the original base. Okay, so taking b and raising it to the negative 1 power, I'm going to turn that into 1 over b. The reciprocal of b is 1 over b. And then I still get that minus 1. And I divide that by 1 plus, well, I get b to the negative 1 power again, so I turn it into 1 over b. So this is the first step. Get rid of your negative exponents, applying the reciprocal. Cool. Now that we've rewritten everything like this is a complex rational expression because it's like fractions inside of a fraction. If I were you, I would use the strategy discussed in our lessons together of finding the LCD of all four fractions. And by the way, I'm turning these ones into 1 over 1 so I can see all the fractions. Cool? You could keep them just as 1, whatever you want to do. But I'm going to multiply everything by the LCD of B, 1, 1, and B, which is just B. So B is the LCD, and I'm going to multiply that LCD on top and bottom. And I'm going to multiply it into all this stuff, like this. That'll clear the fractions. So instead of fractions within fractions, I only have a single fraction now. And B divided by B cancels. And so I just get 1 right there. And then, well, if I multiply B times -1, that's negative B. And now let's move to the bottom. B times 1 is just B. And now I'm adding B divided by B, which cancels, right? B kills B, I just get 1. And this is my final result, 1 minus B over B plus 1. So this exercise taught us a couple things, right? When we deal with negative exponents, we take the reciprocal to turn that exponent positive. In a complex rational expression, we multiply top and bottom by the LCD, and that clears the fractions and simplifies things all the way to this point. Now, this doesn't simplify any further. That's where we get stuck, and that's where we say we're done. Great. Time to move on into our discussion on inequalities. We discussed that for a couple sections of chapter 2. So here I go, problem number 27. Solve this inequality. 78 is greater than or equal to 10x minus 2. And so I will, and I'm going to solve for x. And I'm going to do it as if this was an equation. This is like a linear equation, but it's an inequality. So I'm just going to start by adding 2 from right to left. And 78 plus 2 is 80, and that's greater than or equal to 10x. I'm now going to divide by 10, okay? And I have now gotten x by itself. 80 divided by 10 is 8, so I get an answer. 8 is greater than or equal to x. Now, it's oftentimes a better format to put the variable first and the number second instead of the number first and the variable second. So a lot of students will rewrite this, and mathematicians, they'll rewrite it and they'll say, well, this is written as x is less than or equal to 8. Okay, so what did I just do? I swapped 8 and x, so x came first and 8 came second, but the inequality symbol still has to face the 8. So my inequality symbol is still facing the 8, so we're still good. So you could always take a statement that says 8 is greater than or equal to x and change it into x is less than or equal to 8. That'll help your brain. Another thing that helps your brain to write the solution is to think about what this means on a number line. So I'm going to help you visualize this on a number line, and I'm going to go to 8 on that number line, and I'm going to put a closed dot because x is less than or equal to 8. If x was less than 8, I'd put an open dot, right? But it's less than or equal to 8. And then I shade everything to the left of 8 because x could be any value that is to the left of 8 on the number line. And this helps me report my answer in interval notation and set builder notation. Let's start with set builder notation, all right? So reporting my answer, I would open a set. Here's the start of my set. And I would say x such that. Now this vertical bar, you could type VERT for vertical into your answer box, and it will create that vertical bar. This is also in your tools menu on the right-hand side. When you click into a box, you'll see this vertical symbol. It's representative of such that. Okay, so it's the set of all x values such that. Then we put the inequality in the set builder notation. X is less than or equal to 8. Then we close off that set and we're done. Okay, so this is how you write the answer in set builder notation. The answer in interval notation, we can look at the number line and say, well, this arrow went left forever to negative infinity. We always write interval notation from smallest to greatest, from left to right on a number line. So I'm going to start at negative infinity with a parenthesis, comma, 8, and close it with a bracket. A bracket means that it includes the value 8. All right, moving forward into problem number 28. Solve this inequality, and it's a double inequality. Yeah, I have negative 34 is less than or equal to negative 4 minus 5x, which is less than or equal to negative 14. This is a double inequality. And we want to get x by itself in between the lower and upper bounds. And we can do all the same operations that we're used to. There's only one detail that you need to remember when dealing with inequalities. When you divide by a negative number across the inequality, it flips the inequality's direction. And in a double inequality, it'll flip both the inequality's directions. Let me show you, because it's going to happen. So I'm going to add 4 in all 3 parts of the double inequality. Okay, and I'm going to rewrite my statement. Because negative 34 plus 4 is negative 30. Which is less than or equal to negative 5x, which is less than or equal to negative 14 plus 4, which is negative 10. Yeah, and at this moment, to get x by itself, I need to divide by negative 5. And so I do that in all 3 parts. But when I do that, because I divided or multiplied by a negative number across the inequality, yeah, on both sides, these 2 inequality symbols flip their direction, okay? So let me set us up for success, giving myself a little more space. There we go. And negative 30 divided by negative 5 is positive 6. And I'm flipping the direction of the first inequality symbol, saying it's greater than or equal to x. And I flip the direction of the second inequality symbol as well. And negative 10 divided by negative 5 is positive 2. Cool, so I now have something that says 6 is greater than or equal to x, which is greater than or equal to 2. But I'm not happy with the way this is stated because this is technically the upper bound and this is technically the lower bound, right? Because this number is bigger than this number. So usually we like to write the lower bound on the left and the upper bound on the right. Let me show it to you. Lower bound of 2, upper bound of 6, with x in between. And when I rewrite it, rewriting it kind of backwards, it flips those inequality symbols again. So they both go now in that direction. And so this is the way I would report my answer if I were you. Cool. And so let's do that. We'll report our solution in set builder notation first. And so here I go. I'm gonna write a set. More beautiful set here. There we go. So in the set, I'm gonna put x such that 2 is less than or equal to x, which is less than or equal to 6. So in the set builder notation, we open a set and say x such that, and then we put the inequality notation that we found right there in the set, and then we close the set with the curly brackets. Now let's write this in interval notation. Well, in interval notation, that would be bracket 2, comma 6, bracket. We're starting at 2 and we're ending at 6. We're putting brackets around them because x is, can equal them. X is allowed to equal 2 and it's allowed to equal 6 in this statement. So that's why we get brackets. Let's go again. Problem number 29. Solve this compound inequality and write your answer in interval notation. Now I see 2 separate inequalities and the word or between them. So the strategy for this compound inequality is to solve the 2 inequalities separately and then think about what their solution would be based on the word or between them. Here I go. Let's solve the first inequality for the variable x. I'm going to add 4 from left to right. I get 2x is greater than or equal to 12. I'm now going to divide 2. I didn't multiply or divide across the inequality by a negative number, so my inequality never flipped directions, and 12 divided by 2 is 6. So I get this answer first. Let's move on to the next inequality, this one. Okay, and so now I solve it, and I start by adding 1, and I get negative x is greater than negative 2 plus 1, which is negative 1. I now divide by negative 1 across the inequality. That flips the direction of the inequality, and I get x is less than 1. And between these two inequalities, I had the word or. Now's a great time to think of your inequalities on a number line. You could even stack the two inequalities on two separate number lines and think about what the solution would mean. In this case, it looks like my intervals are going to be two different intervals. So I picked the lower number to go on the left and the bigger number to go on the right of the number line. So I've got 1 and 6. So I put 1 to the left side, 6 to the right side because 1 is smaller, 6 is bigger. And now I think about each one separately. Like x is less than 1, so I'd have an open dot at 1, and I'd shade the region to the left. This is the inequality x is less than 1. Now, when I look at x is greater than or equal to 6, I think, okay, well, at 6 there would be a closed dot, and I'd shade the region to the right of 6, because x is the variable that could be anything bigger than 6, bigger than or equal to. So this is my solution graphically. When you have two regions that are separated, that aren't shaded between them, you are going to use the union symbol. All right? So my solution, I always write it from left to right on the number line, starting on the left side, ending on the right side. So starting to write the solution, I would have negative infinity, comma, 1, with a parenthesis. Why is this a parenthesis? Because there's an open dot at 1. Then I put a union symbol, and I start the next interval at 6 with a bracket, comma, infinity. 6 has a bracket because it's a closed dot, right? X is greater than or equal to 6. So closed dot there. And there's the way I would report my solution in interval notation. Moving forward, problem number 30. Solve this compound inequality and write your answer in interval notation. Negative 5x plus 3 is less than or equal to 8, and 3x minus 3 is less than 9. Now, this compound inequality is different. This one used the word or, but this one uses the word and. So when we get to the end of our solution, we're going to think about what that means, okay? But first, let's solve each inequality separately. All right, so I'm going to solve the first one by subtracting 3 from left to right. And I get negative 5x is less than or equal to 8 minus 3, which is 5. I now divide by negative 5 across the inequality, and realizing I'm dividing by a negative number, I flip the inequality symbol. 5 divided by negative 5 is negative 1, and there we go. I got my first inequality solved. Let's solve the second inequality. So I'll add 3 from left to right, and I get 3x is less than 9 plus 3, which is 12. I now divide by 3, and I have the second inequality solved. X is less than 4. Now, I have the word and in between these inequalities. So what the word and represents is it's where the two shaded regions overlap, okay? So if I were you, I'd actually create two separate number lines, one stacked on top of another. This is what we did in our lesson together. Okay, this was I believe, our lesson 2.6. Okay, and so I put the smaller number on the left and the larger number on the right. Like negative 1 is the smaller number and positive 4 is the bigger number. And then this says x is greater than or equal to -1. So I put a closed dot at -1 and I shade everything to the right. Now this inequality, I'm going to write it on the number line below, x is less than 4. Okay, so I put an open dot at 4 and I shade everything to the left of 4, like this. Okay, now this is where the word and is so important when we get to this point. And means the shaded regions overlap. Okay, so stacked on top of each other, the only places where they overlap is starting here, the red stuff stacked on top of each other, -1 to +4. Okay, I'll write the result on a number line. Like I'm going to combine these two number lines into one and just show off their shaded region that they share in common. Okay, so at -1, I have a closed dot, and at 4, I have an open dot. And the only overlap is the space between these two values. This is my solution. I'm going to report my solution in interval notation. Okay, so I'll get that set up here. In interval notation, I have a bracket, and I'm starting at -1, and I end at 4 with a parentheses. Why do I have a bracket? Because at -1 there was a closed dot. Why do I have a parentheses on the right? Because at 4 there was an open dot. And that's the solution. Moving forward to problem number 31, let's now talk about absolute values, right? That was section 2.7. Absolute value equations, and then we'll move into absolute value inequalities. So when I see this equation, the absolute value of -8 times x equals 40, I first ask myself, is that possible? Because an absolute value can only equal 0 or a positive number. Yeah, this is a positive number, so it works. Now, to drop the absolute value symbols, because that's our goal, is to get rid of these absolute value symbols so we can solve, we create two separate equations. We take the stuff in the absolute value and set it equal to -40, and we take the stuff in the absolute value and make it equal to +40. A little reminder, an absolute value of something is just the distance that thing is away from 0. Okay, so this thing in the absolute value could have been -40 or it could have been +40. Now we solve each of these two separate equations. Let me do it. I'm going to divide by -8 from left to right. And I'll do it again in the second equation. I'll do it simultaneously for you. So in my first equation, I find that x is equal to -40 divided by -8, which is, well, 5. And in my second equation, I find that x is equal to, well, 40 divided by 8. Sorry, 40 divided by -8, which is -5. I have two solutions. So I look at the instructions, enter multiple answers separated by commas, like x equals 1 and comma, x equals 2. So to report my answer, I'll say x equals, well, -5, comma, x equals 5. There you go. There's my two solutions, separated with a comma, in the format that the question asked. Here's problem number 32. Solve this following equation. We have the absolute value of 7x plus 4 equals 5. And it's done the exact same way. To drop the absolute value symbols, we have to create two separate equations. 7x plus 4 equals -5. And then also 7x plus 4 equals 5. Okay, so creating two separate equations. And what we do is we take the stuff in the absolute value, set it equal to the negative version of whatever this stuff is. There it is. And then rewrite the exact equation without the absolute value symbols the second time. Now let's solve both equations. And I'll do it simultaneously since it has the same operations. Like here I'm subtracting 4. I'm going to do it in both cases. So I get 7x equals -5 minus 4, which is -9. And then 7x equals 5 minus 4, which is 1. I now divide by 7 in both cases. and I have my solutions. Okay, so my solutions are negative 9/7 and 1/7. And here, if there are multiple answers, separate them by commas. It didn't say to set them equal to x or anything like that. Here's the example. So I just took negative 9/7 and 1/7, and I said, that's my answer. I'm done. Great. Moral of the story here, when we have absolute value equations, first make sure that the absolute value is equal to a positive number right at the beginning. Yeah, in both cases it was. We proceed to create two separate equations. To drop the absolute values, we have to set the equation equal to the negative version and the positive version of the thing on the right. Then we solve both equations and we're done. All right, well, what about absolute value inequalities? All right, so now instead of an equal sign between the absolute value stuff, we now have a less than or equal to sign in this case. Now, I would refer you back to your 2.7 notes, which are incredible at explaining what we do in these situations, but I'll be very clear. First, we want to isolate the absolute value. You see this -7 right here? Well, we're going to add it to the other side so that we can isolate the absolute value. Rewriting this stuff, I have now the absolute value of 3x plus 3 is less than or equal to 8 plus 7, which is 15. Cool. Now, our goal is to get rid of the absolute value symbols. And we write this as an equivalent statement, taking 15 and making it negative. I'll do it over here. Take 15, make it negative. And now we have less than or equal to 3x plus 3, which is the stuff in the absolute value, right? No more absolute value. We dropped it. Awesome. And we set that less than or equal to 15. Great. So our goal is to create a double inequality. And to do it, we just take this value 15 and we make it negative and we put it on the other side of it all. So now I have a double inequality. It says negative 15 is less than or equal to 3x plus 3, which is less than or equal to 15. This is how you set it up. Now we need to solve this double inequality for x. So you'll see me do all the operations to get x alone. I'm going to subtract 3 and all 3 parts of this. And negative 15 minus 3 is negative 18. And that's less than or equal to 3x, which is less than or equal to 15 minus 3, which is 12. I now divide by 3 across the double inequality. And negative 18 divided by 3 is negative 6, which is less than or equal to x, which is less than or equal to 12 divided by 3, which is 4. And this is my result. Now, you could think about this on a number line. That's always good, so I'll do that really fast. If I create a number line, I found negative 6 and positive 4 were the starting and finishing points, like the lower bound and the upper bound, yeah? And I have closed dots at both those locations, and I shade the region in between. So that's the solution graphically. Now, I'm asked to find my solution and write it in interval notation. Okay, so to write it in interval notation, I would simply take that negative 6 and put it with a bracket, and then put a comma, and then 4 bracket, because I've got closed dots on both ends. That's why I'm putting brackets. And it starts at negative 6 and it ends at 4. And so that's the interval of all the possible solutions of the variable x. Moving forward, let's now talk about a distance problem. Okay, so let's say I know 2 points in space. Negative 5 comma 2 is the first point, and 8 comma 5 is the second point. Now, just to give you a little context, we could call this x1 comma y1. This is the labeling system for the first point. And then x2 comma y2, this is the labeling system for the second point. So we can differentiate the 2 points. And to find the distance between these 2 points, we use the general formula, which I will show off right here. The distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So we're going to plug these values into the distance formula, and I'll show that to you. So distance equals the square root of, well, x2 minus x1 would be 8 minus negative 5. So I take 8 and subtract negative 5, squaring that, plus y2 minus y1, well, that's 5 minus 2 squared, like that. Now, when you plug things in, be careful with negatives, because we already have the minus sign of the formula, and then the negative value comes next. That's a double negation, which we will turn into a positive. Kind of like we saw earlier with the slope formula. When we were applying the slope formula, we saw this happen multiple times. Anyways, now it's time to clean this up, right? This is the square root of, well, 8 plus 5, 13 squared, plus 5 minus 2, which is 3 squared. Okay. Writing this above, I would say, well, this is the square root of 169, right? 13 squared is 169, plus 3 squared, which is 9. And so my final answer will be that the distance is equal to 178 under a square root. The square root of 178. Awesome. This is the exact answer. Your calculator could tell you an approximation of what the square root of 178 is. It's a little more than 13, right? So if I approximated this for fun, then I would get, yeah, 178. That would be about 13.34. Okay, so an approximation, 13.34. But I believe your problem is going to want you to input the exact answer. Cool. Let's go ahead and move forward. And now instead of worrying about the distance formula, like in this last problem, we're now going to focus on the midpoint formula. So we're asked in problem number 35 to find the midpoint between the points negative 1/4, 3/4, and negative 2, 1/2. Now the midpoint formula, I'll show it to you. It's just taking the x values and adding them together and dividing by 2 to find their average. And then we do the same thing for the y values. Take the y values, add them together, and divide by 2. So this is the general formula to be able to do that. Now, yeah, our labeling system is this first point given, that's like x1, y1. And the second point that was given, that's x2, y2. So we're going to use these values, plugging them into this formula. So in our case, we're going to take x1 plus x2 and divide by 2. Well, that would be, like negative 1/4 plus negative 2, and that's divided by 2. Okay, now take the y values. y1 plus y2, that's 3/4 plus 1/2. And then divide that by 2. Okay, so this is our answer, but we just need to clean it up a little bit, right? Like, let's take negative 1/4 and add negative 2 and divide 2 from that. Okay, so this takes a little practice in your calculator. Make sure that you get it right. Okay, and I'm going to do this right now. And I get an answer. I'm going to put it as an improper fraction. I get negative 9/8 for x. Okay. And now for the y values, adding the y values together. Okay. Just one sec. I'm getting this all squared away. Awesome. So I found 5/8 for the y value. Okay, so there you go. Practice inputting these values into your calculator and getting an improper fraction as a result. Okay, there's also the decimal forms, like, the x value in decimal form, -9/8 is -1.125, and then 5/8 in decimal form is 0.625. All right, so this is the answer in decimal form, but I believe you're going to want to input the improper fractions. Awesome. Let's move on to problem number 36. Now simplify this as much as possible, and we see 5 times the square root of 405 minus 2 times the square root of 1125 plus 2 times the square root of 75, and we think, oh my gosh, what is going on here? Okay, and so we're going to move straight into radicals. Okay, that's what this section's about. And our goal is to take 405 and split it into 2 radicals. And then take 1125 and split that into 2 radicals. And then take 75 and split it into 2 radicals. So I'm rewriting all of this stuff. When I see a single radical, I'm going to write 2 radicals. Okay, same thing here, same thing here. Now, when I look at each one of these, I want to find a perfect square and the leftovers, okay, that multiply to make this number. Like 405, it is a multiple of a perfect square. And my goal is to find, what it is a multiple of. And so I take 405 and I could divide it by my perfect squares, like 4 and then 9. And when I divide it by 9, right, I get, it's 9 and 45. So I was able to break things down into 9 and 45. Why did I do that? Because 9 is a perfect square, and 45 is what I have kind of left over right now. Okay, I'm going to move on, and I'm going to think about the number 1125, and I'm going to say, is it a multiple of a perfect square? And so I could take that and divide by the perfect squares, 1, 4, 9, 16, 25, 36, 49. You've gotten comfortable with them. And so I start doing that, and I see, hey, yeah, this is 9 times 125. So 1125 is a multiple of a perfect square of 9. And then looking at 75, 75 is a lot easier. It's 25 and 3. Right? So 75 is divisible by the perfect square of 25. And so now I'm at this point, and I say, do these numbers break down any further? Like, is 45 a multiple of a perfect square? And let's check. So I'm just going through really fast, dividing by my perfect square values, and it is. So 45 is 9 times 5. So I've now got 5 times the square root of 9 times the square root of 9 times 5, okay, minus 2 times the square root of 9, and then I run into 125. Does that break down further? Could I split that into 2 separate radicals? And I think to myself, well, what if I divide it by 25? Yes, it works. So I'm going to also split 125 into 25 times 5 under 2 separate radicals. And now moving on, this doesn't break down any further. This is it. This is good to go. Now that I've done this, I can take all those perfect squares that I had under a square root and simplify them. Like the square root of 9 is just 3. Okay? And then the square root of 9, that's just 3 again. And then the square root of 9 here, that's just 3. And the square root of 25, that's 5. And then over here, the square root of 25, that's 5. And so now you see I have all these products of things. And things are about to get a lot simpler right now. And so I have 5 times 3, which is 15, times 3, which is 45. And I have that many root 5s, 45 root 5s. Now I subtract. Well, 2 times 3 is 6, times 5 is 30, root 5s, right? And now I finish with 2 times 5, which is 10, and that's multiplied with root 3. Now, you'll recall that radicals are like radicals if they have the same index in the same radicand. So I see the square root of 5 here and the square root of 5 here. So these two terms have like radicals, and I can combine them together. So my final step, my very final step, is 45 root 5 minus 30 root 5, which is 15 root 5. And now I still have the plus 10 root 3. There you go. I've taught you how to simplify these by hand, right? How to think about the simplification process and get it as simple as you can just by thinking about these numbers and dividing out perfect squares and separating a radical into two separate radicals with the product rule of radicals. Okay, let's move on to problem number 37, which says find all real solutions of this equation. And it says x minus 4 squared minus 16 equals 0. So to do it, we're going to use the square root property that we learned about in chapter 9. So first I'm going to add 16 from left to right. Okay, I'm trying to get the thing that is squared by itself. This is x minus 4. That's what's being squared. It's now equal to 16. Okay, and now that I have the thing that is being squared by itself, I can apply the square root property, which says when I square root both sides of an equation, I need to include a plus or minus sign because there are two possible solutions for what the stuff under the radical could be. And so I end up with x minus 4 equals plus or minus the square root of 16, which is 4. Okay, so I simplified the square root of 16. It's 4. At this point, all I have to do is add 4 to the other side. So I'm going to add this 4 to get x all by itself. So I'll write my solution up here. X equals 4 plus or minus 4. And we can separate this into two separate solutions, like 4 minus 4 first, and then 4 plus 4 second. And 4 minus 4 is 0, and 4 plus 4 is 8. So my two solutions for this quadratic equation are 0 and 8. They're both real solutions. They're both real numbers. All right. Great. Let's go ahead and move forward into problem number 38, which says fill in the blanks to make a perfect square. Okay. Our goal is to create a perfect square trinomial so that we can factor it into a binomial squared. Here's how you do it. You take the b value, divide it by 2, and square it. Okay? So the b value is the value that goes with the linear term. In this case, that is 14. In the second case, that's negative 8. And in the third case, that's negative 20. So those are the b values. To complete the square, take the b value, in this case 14, divide it by 2, and then square it. Now, 14 divided by 2 is 7, and 7 squared is 49. So that's what goes here. Let's try it again in the second case. Let's take negative 8. Okay, now divide it by 2 and square it. Well, negative 8 divided by 2 is negative 4. And negative 4 squared is positive 16. Remember, when you square a negative number, the result is positive. Moving on, let's take the b value of negative 20 and divide it by 2 and square it. Negative 20 divided by 2 is negative 10. And negative 10 squared is 100. So I put 100 here. Now, when you factor the perfect square trinomials, okay, we get a binomial squared, a binomial multiplied by itself. And in this case, the answers that go here, here, and here are just b divided by 2. Whatever b divided by 2 is, you can write that here. Okay, so 14 divided by 2, 7. Cool. Okay, negative 8 divided by 2 is negative 4. I already have the minus sign right here, right? The minus sign of the negative. So all you have to do is put 4. And then b divided by 2, in this case, negative 20 divided by 2 is negative 10. So that's why we're putting a minus 10. Great. And there you go. We have completed the square, right? That's the process of completing the square, which we learned in section 9.2, and then factoring it into a binomial that is squared. Important skill for the future. All right, here we go. Problem number 39. Solve the quadratic equation by taking square roots. So we're going to use the square root property here, and let's go. First, I'm going to get the thing that is squared isolated by itself on one side of the equation. That's x plus 5 squared, and it equals negative 9. Next, I'm going to use the square root property. To undo squaring, we square root. So I square root both sides, and I would always remember to include a plus or minus sign when I square root both sides of an equation. Okay, so there are two solutions to a quadratic, and that's why we have this plus or minus symbol to represent the two different solutions. So the square and the square root, they fight and die, and I get x plus 5 equals plus or minus the square root of negative 9. Now, at this point, we've discussed, hey, when we have a negative number under a square root, that's an imaginary solution. So you can make that negative become positive as long as you multiply an I before or after the square root. Okay, so it's multiplying on I before. It doesn't matter if you do it before or after the square root because multiplication is commutative. And so now I get the answer of the square root of 9, which is 3 times I. But before I'm all the way done, I first have to subtract 5 from the left side to the right side to get my answer, which is x equals negative 5 plus or minus 3i. Now, let's read the instructions here. If there is more than one correct answer, enter your answers as a comma, separated list. And if there are no real solutions, enter none. Turns out, when I have this I, that's an imaginary solution. It's not a real solution. Therefore, there are no real solutions. Okay, this is the answer, but it's not real. So we're going to go here and we're going to write none as our final answer. Great. Now, when would you have realized that this is the final answer? You could have stopped right there. When you saw a negative number under the square root, when we originally got there, that's when you could have said there's no real solutions. I thought it would be fun to send us to the final answer there, though. Now, problem number 40 says find the discriminant of the equation, 5x squared plus 4x plus 4 equals 0. Now, here's a reminder about the discriminant, which we learned about in section 9.3. The discriminant is a part of the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and it helps us solve all quadratic equations in this world. It's amazing. But the discriminant is just the stuff inside the square root. It's the b squared minus 4ac stuff, okay? Where a is the quadratic coefficient, b is the linear coefficient, and c is the constant coefficient. In this case, they're all positive, right? A is 5, b is 5, and c is 4. Okay, quadratic coefficient, linear coefficient, constant coefficient. Always look for the signs, right? If they're negative, be careful. They're negative, okay? Now let's plug those values into this discriminant formula. Okay, so b squared minus 4ac, that is the discriminant. And so b is 5, and I'm going to square it, minus 4 times a, which is 5, times c, which is 4. Okay, and cleaning that up, that gives me 25 minus, well, 4 times 5 is 20 times 4, 80. Oh my goodness, 25 minus 80 gives me negative 55. That's the discriminant's value. Okay, and the discriminant helps us discriminate how many solutions there are. So we could have two real solutions. That's if the discriminant's result is positive, if it's greater than 0. There could be one real solution. That's if the discriminant equals exactly 0. So if it equals 0, there's only one real solution. And 0 real solutions happens if the discriminant is negative. Looking at my case, I got a discriminant value that was negative. And a negative number under a square root, well, we already saw that that creates an imaginary set of solutions. So that's why we're going to say there are 0 real solutions when we have a negative discriminant. Let's repeat that one last time. When the discriminant is a positive value, there are 2 real solutions. When the discriminant equals 0, there is 1 real solution. And when the discriminant is negative, there are 0 real solutions. Moving forward into problem number 41. Yeah, problem 41. This equation has 2 solutions, A and B, where A is less than B. And here is the quadratic. Okay, so my goal is to solve this quadratic equation and find the 2 solutions. And then I'll report the smaller number as A and the larger number as B. Now, when I look at this, I think, well, can I factor it? Because solving by factoring is the first thing that we would want to do. But it turns out we can't. There aren't 2 numbers that multiply to negative 15, but sum to positive 6. And so I will go immediately into using the quadratic formula. And I'll say, well, my A value is 1, my B value is 6, and my C value is negative 15. And plugging that into the quadratic formula, I get x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all divided by 2 times a. All right, so it's a good moment to stop. Do you know the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and then what I've done is I've taken those a, b, and c values and I've input them into the formula. And I see that I could have made a mistake right here, but I'm going to fix it. See this, I wrote 15 here, but it's not 15. It's negative 15. Just give me one sec. There we go. Negative 15, all fixed. Okay, so now what I'm going to do is I'm going to evaluate this. And I'll do it by hand. Now, we've worked on inputting it into a calculator in the past. Sometimes you can input it into a calculator because there's a real solution. Okay, and sometimes we can't. Sometimes our calculator will tell us domain error. Anyways, I'm going to start cleaning this up. 6 squared, it's 36. And then negative 4 times 1 times negative 15 gives me a positive 60. So I'm actually ending up adding 60 in the square root. And then that's divided by 2. Let's take this a little further. Like 36 plus 60 is 96. So I have negative 6 plus or minus the square root of 96 divided by 2. And 96, you see, it's a multiple of a perfect square. So we could, kind of clean this up a little bit. I'll do this up top. Negative 6 plus or minus, and the square root of 96 can be broken down into the square root of 4 times the square root of 96 divided by 4, which is 24. So there you go. Got that. And does it break down even further? Like 24, is it a multiple of a perfect square? Well, yeah, it's a multiple of 4. So I could break 24 into the square root of 4 times the square root of 6. There we go. So we can take things even further sometimes. Great. And that's all divided by 2. Now, the square root of 4 is 2, so I'll rewrite that as 2. And then the square root of 4 here is also 2. All right. So I'm just little by little cleaning this up until I get, well, negative 6 plus or minus 4 root 6 over 2. And for the last trick, negative 6, 4, and 2 are all divisible by 2, so I can reduce this and I can report my final answers. Okay, so I'll reduce this into negative 3 plus or minus 2 root 6. Okay, so this is my solution. But I'm going to split it into 2 solutions. And I'm going to put the smaller number first as A, and the larger number second as B. Reporting my answer, I have negative 3 minus 2 root 6. That's the smaller number. And then negative 3 plus 2 root 6 is the larger number. right? Because well, when I subtract 2 root 6, that's going to be less than adding 2 root 6 to this initial number that we started with. That's the reasoning, okay? So pick the minus version as the smaller number, the plus version as the larger number. Great job. Well, let's try this type of thing again. We're just getting comfortable with this. So what we did in problem number 41, let's try it again in problem number 42. And so looking at this quadratic, one thing that's good to do is see if you can reduce by a certain factor. So if I divide out a 2, because all of these are multiples of 2, I could just divide out a 2 and rewrite this with smaller terms. Like now I have 2x squared plus 5x plus 1 equals 0. So if you ever want to make your life easier, you could do that trick. Now, you don't have to. You could write the original a, b, and c values as 4, 10, and 2 and plug them into the quadratic formula. You'll get the same answer. But I'm going to do the reduced versions for ease of being able to clean it all up, 2, 5, and 1. So here I go. I'm going to input these a, b, and c values into the quadratic formula, and x equals negative b plus or minus the square root of b squared minus 4 times a times c. And that's all over 2 times a. Okay, I've input those values. Now my goal is to clean this all up. So here I go. X equals negative 5. The first thing you want to do is clean up the stuff in the square root, the discriminant. Right, that's b squared minus 4ac. That's the discriminant. And so I have 25 minus 8, which gives me 17. Yeah, so that cleaned up pretty fast. Now I'm going to just take that result and divide it by 4, because 2 times 2 gives me that 4. And this is my final answer. I got it. It doesn't reduce any further, right? It's not reducible as a fraction. It's all cleaned up. And 17 is a prime number under a square root, so I can't simplify that any further. And so I'll report my two answers. First, I'll report the minus version. That's negative 5 minus the square root of 17 divided by 4. And then the second answer is the plus version, negative 5 plus the square root of 17 divided by 4. And so there's my two solutions. All right, let's move forward into problem number 43. Oh, that brings us to our last page. That feels good. Problem number 43 here says you will build a rectangular sheep pen next to a river. There is no need to build a fence along the river, so you only need to build 3 sides. You have a total of 530 feet of fence to use, and the area of the pen must be 35,100 square feet. Find the dimensions of the pen. Okay, I'm going to zoom in here and I'm going to show you my process. Great. So with the context of this word problem, I would create a diagram. And so I have this river, and that river acts as one of the sides of my rectangular pen, right? We're talking about a rectangle here. And so I'm going to have the pen coming out, and then down, and then reconnecting back to the river again, like this. Cool. Now, talking about a rectangle, you'll remember that the perimeter of a rectangle is usually 2 times the length plus the width. But in this case, well, let's say the length is this here and here, and the width is this. Well, the second width is missing, right? If I call this the length here and here, okay, well, the second width, I don't need that for fencing, okay? So my perimeter in this special case is really just 2 times the length plus the width. That's the perimeter of fencing that I'm going to use. And of course, the area of a rectangle is length times width. So we're going to be using these two formulas, right? We know the perimeter of a rectangle and the area of a rectangle, and things are just slightly adapted for our unique situation where One side of the rectangle is the river instead of the fence. Okay, so what could I do here? I could use those formulas like perimeter equals two times the length plus the width, right? So I'll set that up. And what is the perimeter's value? They told it to me. It's 530. Okay, so I have 530 feet of fence to use. So my perimeter is 530. Then if I multiply the length times the width, that'll give me the area. And they told me that that area has to be 35,100 square feet. That's the area. So I know the length times the width is equal to the area of 35,100. Now, what we've just done together is we've created a system of equations. Here's the system of equations. And if we solve the system of equations, then we will know what the width and the length will be for this certain scenario. Okay? So I'm going to use the substitution method to solve this system of equations. I'm going to take the first equation and solve it for W. That's the easiest variable to solve for. So I'll say W equals, well, 530 minus 2 times the length. What I've done is I'm subtracting 2 times the length to the other side of this equation, getting the variable W alone. Now that I've gotten the variable W alone, I can substitute what it is into the second equation for W. Okay, so this stuff right here that I just said W is that stuff, so I can go to W here and plug it in. Rewriting my second equation, L times W equals 35,100, I can write it as L times 530 minus 2L equals 35,100, like that. Now, if I distribute L into both of these terms, I'll discover that I have a quadratic equation. 530 times L minus 2 times L squared equals 35,100. That's a quadratic equation. And so now our goal is to solve the quadratic equation for L. Okay? So that is kind of the last little bit to do. And so we try it. We're like, okay, how do we solve a quadratic equation? First, set it equal to 0. Now, I never like my quadratic term to be negative, so I'm going to add this to the other side, and then add this to the other side. You'll see me do it. So explicitly, I'm going to take the 530L, and it's positive, so I'm subtracting 530L to the other side. And then take the negative 2L squared and add it to the other side like this. And so now my quadratic equation says, I'll write it over here, 2L squared minus 530L plus 35,100 equals 0. That's what it says. Okay, so at this point, I'm now going to take things further, and maybe I solve with the quadratic formula, right? So you could use the quadratic formula. The A value is 2. The B value is, forgive me, negative 530. So just cleaning this up a little bit. I need to fix that little bit right there. Just a sec. Fit in that 0. Ha, fixed. Okay, and my C value is 35,100. Now, using the quadratic formula, I come to 2 different solutions for L. And so I'll just write what those solutions are. The first solution comes out to, looks like 160. And the second solution comes out to 165. Okay, so I've just used the quadratic formula. I'm going to let you apply that to get these answers. Okay? And so I now know that I have 2 solutions for the length. The first one is 160. The second one is 165. So we've got that all figured out. Now we have to figure out what the width is, right? So we figured out what these two lengths are. What is the width? And so I'm going to use perhaps the second formula right here. Length times width equals 35,100. And I'm going to plug 160 in for the length right there, and then 165 in for the width, or for the length as well. Okay, so I end up with this statement that says the width, it's equal to 35,100, and that's divided by 160. And then I do the same thing, 35,100 divided by 165. Those are my two solutions. Cool. So let's go ahead and compute those really fast. Forgive me, these aren't 165 and 160, they're 260 and 265. Okay, so that's what I ended up getting. And so dividing out each one of those, I get, well, 130 for the width in this case. Okay, and then one more time, I've now got 35,100 divided by 265. Okay, and I get my second answer, which is 135. Awesome. So we were able to make it through problem number 43. Please be sure to use the quadratic formula right here to go to your two solutions to get for length. Moving on to problem number 44. Given that f of x equals 5x minus 8 and g of x equals 3x plus 6, calculate f of g of x. So that's our first objective. So the reminder, this is composition of functions. This is not multiplication, this is composing them. So we're going to plug the g of x function into the f function like this. When I see f of g of x, I rewrite it as f of g of x. And so now thinking about that, what that means is we're going to plug the g of x stuff right here in for x in the f function right there. So writing the f function, I have 5 times, when I get to the x, I replace it with 3x plus 6, the g of x stuff. And then I subtract 8. There we go. So I'm writing the f of x function, but when I get to x, I write the g of x stuff for it. We have evaluated or composed these two functions, right? We've composed them together now, but we have to simplify. And so to simplify, just distribute here and here. And we get 15x plus 30 minus 8. And then we combine any like terms, right? So 30 minus 8 is 22. And so I get 15x plus 22 as my f of g of x composed function. That's the result. And then the domain, since the domain of these two functions are all real numbers, because they're lines that go on forever, left and right, the domain is just all real numbers. Okay, moving on. Let's compose the other way around. So instead of f of g of x, we're going to compose g of f of x with these same two functions, right? This is the same two functions here. And so in this case, I'm going to start writing the g of x function and input the f of x function stuff for x. So here's the g of x function. Okay, there it is. What I'm going to do is take the f of x function stuff and plug it in for x right there in the g of x function. Here I go. 3 times 5x minus 8 plus 6. Right? I started writing the g of x function. 3. When I got to x, I replaced it with the f of x stuff. Yeah, there it is. And then I added 6. I continued to write that g of x function. You've composed g of f of x now. Great job. But we need to simplify. So we're going to just distribute and combine any like terms that we can. So I get a 15x minus 24 plus 6. Writing my final result, I have 15x and then minus 18. Negative 24 plus 6 is negative 18. And surprisingly enough, once again, I just got a linear function out of it. And you'll notice this is different than this, right? F of g of x is not the same thing as g of f of x. But one thing that they do share in common is their domains are all real numbers, because we had two lines that we were composing together, and lines are infinite. Like their domain goes from negative infinity to infinity. Okay, so all real numbers, same as this one above. Let's now have a little fun. Let's go ahead and plug the f function into the f function. Pretty impressive. Okay, so to do that, I'm going to take f of x. And so I'm going to start writing the f function, 5. But when I get to the x, I'm going to replace that x with all of the f of x function stuff, 5x minus 8. And then I subtract 8 at the end of it. Okay, so it's kind of this interesting thing where I started writing the f function, and then when I got to x, I input the f function into the f function. You've now composed the two functions together, and let's now clean it up. We'll distribute and combine any like terms. So I get 25x minus 40 minus 8. And now I write my final result. F of x equals 25x minus 48. And as you would suppose, the domain is all real numbers. And let's try this again, but now instead of f of x, we're going to try g of x. So I'm going to plug the g function into the g function. Pretty cool. And so I start writing the g function, 3, and when I get to x, I replace it with 3x plus 6, and then I finish writing the g function plus 6. Yeah, so I'm writing the g function out, right? 3x plus 6. But when I got to x, I replace it with 3x plus 6. It's like Inception. Okay, so now I distribute that 3 in, and I get 9x plus 18 plus 6. Okay, and writing my final result, I now have 9x plus 24. Okay, that's a simplified version of g of x. And yep, guess what? The domain is all real numbers again. Okay, moving on. Problem number 45. Let the function f be defined as f of x equals 4x plus 6. And our goal is to find f of 2 and f of 3. Now here's a hint. First, figure out what's inside the parentheses. So I'm only going to look at the inside function stuff of the parentheses. Okay, and I'm going to address this one first. And I want to find f of 2. So I go up to my function and I ask, hey, what's f of 2? And that's equal to 4 times 2 plus 6, because I'm just inputting 2 into the function. And 4 times 2 is 8, and adding 6 on, I get 14. Okay, so I just found out f of 2 is 14. Now that I know what f of 2 is, it's 14, I now want to find what f of 2 is. But I already know f of 2 is 14. That's what I found. Its output is 14. So I'm going to replace that f of 2 with 14. Okay, so now my objective is to find f of 14. So I plug 14 into the function. 4 times 14 plus 6. And I get my answer. That's a 62, looks like. Okay, so this is my answer for f of 2, 62. All right, so that's the process, right? First, I looked inside at the inside function. Like that's part of the hint right here. So I find what f of 2 is. When I found f of 2, it was 14. And so I can replace f of 2 with 14 and then input the 14 into the function and get 62 as my output. I'm done. Let's try that for the same scenario, but now I want to find f of 3. So now my input is 3. Here I go. And I'm going to kind of just set this up for success here. So you see the whole process done in the same type of way. So first I want to find f of 3. So that's equal to 4 times 3 plus 6, right? I'm just plugging 3 in for x in the function. 4 times 3 is 12. 12 plus 6 is 18. That's my output, 18. So now I want to find not just f of 3, but f of 3. And f of 3 I found was 18. Okay, so I'm going to plug in 18 to the f function. All right, so there I go, plugging in 18. 4 times 18 plus 6. That looks like it's 78. Okay, so 78 is my output. There we go. We went through that process a second time to kind of get you comfortable with composing functions with a certain input value. So we're evaluating composite functions. Moving on to problem number 46. Find the inverse function of f of x equals 6x minus 2. Now, in our notes of section 10.1, we talked about this, and we talked about a four-step process. And that four-step process begins with turning f of x into y. So step 1, turn f of x into y. Here I go, y equals 6x minus 2. Remember, f of x is y, so we could always do that. We could always turn f of x into y or y back into f of x. Now that we've completed step 1, we're going to move on to step 2, which is to swap your x's and your y's. Like this y literally becomes x, and this x literally becomes y. We've swapped them. Y became x, x became y. Now that we have swapped the x and the y values, we're now going to solve for y. That's step 3, solve for y. To do that, I'll add 2 from right to left, and then I'll divide 6, right? So I'll get x plus 2 divided by 6 equals y. And step 4 is to turn y into f inverse of x, because now y is the inverse function of x. And so this answer that I got when I solved for y, x plus 2 over 6, that's the answer, x plus 2 over 6. Now, to kind of do a quick check of if you got the inverse function, all of the inverse operations should be happening to x from the original function. So, you know, in this original function, f of x equals 6x minus 2, well, x had a minus 2. So in the inverse function, it should have a plus 2, opposite operation. Yep, it does. And in this original function, 6 was multiplying x. The inverse of multiplying by 6 is dividing by 6. So it looks like this is the inverse function. Great. Now part B, the graphs of f and f inverse are symmetric with respect to the line defined by y equals blank. Well, that is y equals x. So for all of us, this is the answer. Okay, a function and its inverse have a symmetry, a graphical symmetry over the line y equals x. Why is that? Because we're literally just swapping x and y. Okay, here we swapped x and y to get the inverse function. When we do that, graphically, it swaps over that y equals x line. Problem number 47, the table below gives values of an invertible function. Okay, so here I have a function. These are the x values of the function, and these are the y values. Remember, f of x is just y. Y is a function of x. Anyways, what happens for a function, we input values into a function and we get outputs, right? So this 0 is an x value that we input into the function. So to state what the answer for A is, we just have to look at the table. So we say, well, when x is 0, what is f of x? Well, that's 2. That's my answer. Okay, so this table, right, we're just saying, hey, what's f of 0? What's f of an x value of 0? We go to an x value of 0, and that answers 2. Okay, for part B, it's doing it backwards. It's saying f of what value equals 0. Now, this is an output value now instead of an input value. So I go to f of x, and I go to a 0, an output of 0, and the x value that caused that to happen was 1. So that's what I'm going to put right here, 1. According to this table, f of 1 is 0. Now, if we think about things as an inverse of the original function, things go backwards now. So instead of inputting x values into the inverse function, we're thinking about that as y values. Okay, so f inverse of 0, I would go to a y value of 0, boom, and look at the x value. That would be 1. This is the answer. Now, looking at this one, f inverse of blank equals 0. I would go to an x value of 0, and I would see that the output would be 2 typically, so I put 2 right there. All right, so for parts C and D, we had to think about things in the opposite direction, right? Opposite way, because we're talking about the inverse function. Okay. Problem number 48, solve the given equation for x. And this is an exponential equation, 3 to the 5x equals 27. So when we see an exponential equation where the variable x is in the exponent, we want to try to make the bases the same. Okay, so 27 is a perfect cube of 3, so I'll rewrite this as 3 to the 5x equals 3 cubed. Once again, 27 is 3 cubed. Now that we made the bases the same, we can disappear the bases. We can literally make them disappear and set the exponents equal to each other. Now, we simply solve this linear equation that we resulted. And so x equals 3/5. This is the answer. Great. The moral of this story is we want to see if we can make the bases the same. So 27 is 3 cubed. Now the bases are the same. We can disappear them. Set the exponents equal to each other and solve that simple linear equation. That's it. Number 49, find the solution of the exponential equation in terms of logarithms, or correct at least to 4 decimal places. Okay. So checking this out, I have 5 to the x equals 15. Now, if I were you, I would write this in a logarithmic notation. Okay, so we can change stuff from exponential notation to logarithmic notation, and we practice that in our 10.3 lesson. So first write log, then write the base, and then write the result, and it's equal to the exponent. Okay, so there you go. Log base 5 of 15 is equal to x. We have now solved. Okay, in your calculator, you can write this as a common logarithm or a natural logarithm if you do log of 15 divided by log of 5. So I wrote it as a common logarithm. What I'm doing is the base change formula. I took log of 15 and I divided by log of 5. This is the result. Okay, now this is the exact answer, by the way. This is the exact answer, but we've been asked to write it to 4 decimal places if possible, if you want to. So you can write your answer as log base 5 of 15. That's one way to report your answer. If you want to do it as a decimal to get a decimal approximation, that's when we would take log of 15 and divide by log of 5. Okay, this is a base change formula. And inputting that into a calculator, that would give you an answer of 1.6826. Okay, 1.6826. There we go. So that's an approximation rounded to 4 decimal places. So take your pick. You could either do it this way or you can report the exact answer. But no matter what, you're going to have to write an exponential equation in logarithmic form. What you do is you write log first, then look at the base, it's 5, so you make that the subscript. Then look at the result, it's 15, you put it in the logarithm, and it equals the exponent. In this case, it's x. We have solved for x. Problem number 50, find the solution of the exponential equation in terms of logarithms or correct to 4 decimal places. Okay, same instructions as above. Now, I'm going to first get the base with its exponent alone, so I'm going to divide by 9. Okay, that gets the base e with its exponent x all alone, and it equals 10/9. At this point, I'm going to write this as a logarithm. So exponential notation, converting it to logarithmic notation, I write log base e of 10/9. That equals x. Now, when I have a base of e is the natural base. It's 2.7182818828 ... It goes on forever like pi. And you've been taught that you can write log base e as the natural logarithm. So we write ln. Okay, so I have the ln of 10/9 equals x. This is the exact answer. In your calculator, you can type the ln of 10/9, right? So the ln of 10/9 would give me a decimal. I could report that decimal to 4 decimal places. So it's approximately equal to 0.1054. Okay, so this is an approximation rounded to 4 decimal places. All right, so you could input the natural logarithm, ln of 10/9, and you would be correct. But you could also input this as a decimal, 0.1054. Either way that you prefer, you're good to go. Hey, thank you. We just made it through the 50 problems of this review, this final review, and best wishes to you as you prepare. Have a good one. Take care.